In the world of software development, Git reigns supreme as the go-to version control system. Its power lies in its ability to track changes, manage different versions of code, and facilitate seamless collaboration among developers. Among the many powerful features Git offers, merging and rebasing stand out as essential tools for integrating code changes from different branches into a main code base. Mastering these operations is crucial for maintaining a clean and organized commit history, which is essential for efficient debugging, tracking progress, and collaborating effectively within a team. Conversely, a messy or convoluted history can lead to confusion, errors, and wasted time. By understanding the nuances of each operation, developers can make informed decisions about which approach is best suited for different scenarios, ultimately leading to a more streamlined and efficient development workflow. Git merge is a fundamental operation that allows developers to combine changes from one branch into another. It's the most common way to integrate changes from feature branches into the main development branch, often referred to as the main or master branch. The merge operation takes the contents of the source branch and integrates them into the target branch, creating a new merge commit that represents the combination of both branches. One of the key benefits of using Git merge is its non-destructive nature. When you perform a merge, Git preserves the entire history of both branches involved. This means that every commit from both the source and target branches remains intact and accessible, providing a comprehensive record of the project's development. If there are no conflicts, Git will create a new merge commit on the target branch, effectively integrating the changes from the source branch. Git rebase offers an alternative approach to integrating changes from one branch into another. Unlike merging, which preserves the history of both branches, rebasing rewrites the commit history by applying the commits from the source branch onto the target branch as if they were made directly on top of the target branch's latest commit. This results in a linear and streamlined commit history, often preferred for its clarity and ease of navigation. Rebases are particularly beneficial when working with feature branches that have diverged significantly from the main branch. By rebasing the feature branch onto the main branch before merging, you can avoid a messy merge commit and maintain a cleaner project history. However, it's crucial to understand that rebasing rewrites history, which can have implications when working with shared branches. Therefore, it's generally recommended to avoid rebasing public branches that others might have cloned or branched from. Both Git merge and rebase offer valuable approaches to integrating code changes, but they differ in their execution and resulting commit history. Choosing the right strategy depends on the specific context and the desired outcome. Merging is generally preferred when preserving the complete history of both branches is crucial, especially when working with public branches or collaborating with a large team. Rebases, on the other hand, excel at maintaining a clean and linear history, making them well suited for integrating private branches or working with smaller teams where history rewriting is less of a concern. When working with public branches or collaborating with a large team, merging is often the safer and more transparent approach. However, for private branches or smaller teams, rebasing can be a powerful tool for streamlining the commit history and simplifying the development process. In addition to merging and rebasing, Git provides another useful operation called squashing, which allows developers to combine multiple commits into a single commit. This can be particularly helpful when working on a feature branch where you might have made numerous small commits during the development process. Squashing these commits into a single commit before merging or rebasing can result in a more concise and meaningful history. Squashing commits is especially beneficial when you have a series of commits that are only relevant within the context of the feature branch. For example, you might have made several commits to fix a bug or refactor a specific piece of code. Squashing these commits into a single commit with a clear and descriptive message makes the history easier to understand and navigate. To squash commits, you can use the interactive rebase command, which allows you to select specific commits and choose how to combine them. When working on collaborative projects with shared branches, it's crucial to establish clear guidelines and best practices to avoid conflicts and maintain a healthy Git history. One fundamental rule is to avoid rebasing public branches that others might have cloned or branched from. Rebasing a public branch can lead to inconsistencies in the commit history, making it difficult for collaborators to synchronize their changes. Instead of rebasing public branches, consider using merging as the primary method for integrating changes. Merging preserves the complete history of both branches, ensuring that everyone's contributions are reflected in the main branch. Regularly pulling changes from the main branch and resolving conflicts promptly can also help prevent integration headaches. By staying in sync with the main branch and addressing conflicts as they arise, teams can ensure a smoother and more efficient development workflow. For developers seeking more granular control over their commit history, Git offers interactive rebasing. Interactive rebase allows you to reorder, edit, combine, or even delete commits during the rebasing process. This level of control can be incredibly powerful for cleaning up a messy history or preparing a branch for a pull request. To initiate an interactive rebase, you use the git rebase, I command followed by the commit onto which you want to rebase. This will open an editor listing all the commits that will be rebased, along with instructions on how to manipulate them. You can then modify these instructions to perform various actions, such as reordering commits by changing their order in the list, squashing commits by changing the command from pick to squash, or editing commits by changing the command from pick to edit. Interactive rebase provides a flexible and powerful way to fine-tune your commit history, but it's important to use it with caution, especially when working with shared branches. While Git excels at merging changes, conflicts can arise when there are competing changes in the same lines of code, or when files have been renamed or deleted in one branch but modified in another. Merge conflicts are a common occurrence in software development, and understanding how to resolve them is crucial for a smooth workflow. When a merge conflict occurs, Git will pause the merge process and highlight the conflicting areas in the affected files. You'll then need to manually resolve these conflicts by choosing which changes to keep, which to discard, or by combining the changes from both branches. Once you've resolved all conflicts, you can stage the changes and continue with the merge process. Effective communication with team members can also be invaluable in understanding the context of the changes and finding the best resolution. Even with the best practices in place, mistakes can happen, and sometimes you might need to undo a merge or rebase. Fortunately, Git provides mechanisms for reverting changes and restoring your repository to a previous state. To undo a merge, you can use the git revert command followed by the hash of the merge commit you want to undo. This will create a new commit that undoes the changes introduced by the merge commit, effectively reverting the merge. However, it's important to note that reverting a merge doesn't delete the merge commit from the history. Reverting a rebase can be more complex, especially if the rebase involved rewriting a significant portion of the history. In some cases, you might be able to use git reflog to identify the commit before the rebase and then use git reset to restore the branch to that commit. Mastering Git operations, particularly merging and rebasing, is essential for any developer looking to enhance their version control workflow. Understanding the nuances of each operation, their respective use cases, and potential implications empowers developers to make informed decisions that align with their project's specific needs. While merging provides a safe and transparent approach for integrating changes, particularly in collaborative environments, rebasing offers a powerful way to maintain a clean and linear history, especially for private branches or smaller teams. By carefully considering the context and choosing the appropriate strategy, developers can streamline their workflow, minimize conflicts, and ensure a healthy and manageable Git history. By embracing the diverse capabilities of Git and adopting best practices for collaboration and version control, developers can unlock the full potential of this powerful tool and elevate their development process to new heights.